All right, let's dive into something that sounds a little bit crazy in the world of Bitcoin. We're going to tackle a place where the word compressed doesn't mean smaller. In fact, as you're about to see, it means the exact opposite.
I mean, think about it, right? You compress a file to make it smaller to save space. But what if choosing the compressed option actually made your file bigger than the original? It sounds like a bug or just a flat-out mistake. But in the world of Bitcoin private keys, this isn't an error. It's a deliberate design choice. And the reason for it is, well, it's surprisingly clever.
But before we can solve that mystery, we need to get to know the main character in our story, the private key. Because at its heart, it's a really simple thing that just happens to wear a lot of different disguises. So let's just strip away all the jargon for a second. At its absolute core, a Bitcoin private key is nothing more than one single, secret, incredibly long number. That's it. This number is literally the key to your digital castle. It's the one and only thing that proves you own and gives you control over your Bitcoin.
Now, that one secret number can show up in a few different formats. It's kind of like how you can write the number 10 as 10, or the word 10, or even the Roman numeral X. They all mean the same thing. So here, you're seeing three different outfits for the very same key. Hex is the raw number, and the other two, with and with compressed, are special formats designed to make it safer and easier to move that key between different crypto wallets. And it's those last two formats, with and with compressed, that get us right into our central puzzle. Their names are the source of all the confusion, and this is where that paradox really starts to take shape. Okay, so on the surface, the difference looks pretty simple. The standard format on the left, WIF, it always starts with a 5. The so-called WIF compressed one on the right, that one starts with a K or an L. But the real clue here is what they signal. You see, every private key has a matching public key, which is what creates your Bitcoin address. And these formats are actually instructions telling a wallet whether to create an uncompressed public key or compressed public key. And that little detail, well, that's the key to this whole thing. Okay, let's do it. Time to bust this myth wide open and get straight to the truth behind this compression label. And you don't have to take my word for it. Here it is, straight from the Bitcoin wiki itself. The term compressed private key is, and I quote, a misnomer. The private key itself isn't being compressed at all. So if the key isn't actually getting any smaller, what is going on here? This is where you can literally see what's happening. The top line is our private key in its raw hexadecimal format. The bottom line is what we call the compressed version. Now look really close at the very end of that second key. See it? It's the exact same number, but with one tiny addition. A suffix, a little 01 has been tacked right onto the end. So yeah, let's just be crystal clear about this. The compressed private key is actually 1 byte longer than the original. It is bigger, not smaller. So we've solved the paradox of the name, but that just leads to a much bigger question, right? Why on earth would you add that extra byte? And that brings us to the real reason for all this weirdness. That extra byte isn't for shrinking data, it's for sending a message, a secret signal, if you will. The whole point of this extra 01 has absolutely nothing to do with saving space. It's all about communication. It's a clever way to make sure that when you move your key from one wallet to another, the new wallet knows exactly what to do with it. Let's just walk through how this little signal works. So first, like we saw, that 01 gets added to the end of the raw private key. Second, this simple addition changes the final format, and that's what flips the prefix from a 5 to a K or an L. Third, that new format is the signal. It's telling the wallet, hey, the private key isn't compressed, but you need to generate a compressed public key. And finally, that tells the wallet to go search the blockchain for addresses that are tied to that specific type of public key. It's a simple flag that points the wallet to the right place to find your funds. So, this is a neat bit of technical history, but what does it actually mean for you, the user? What happens if this signal gets mixed up or ignored? Well, the consequences can be pretty alarming. This signal is basically a set of directions. If a wallet gets the signal correctly, it knows exactly how to find your Bitcoin. Now, it's worth pointing out that this is mostly a history lesson at this point. Most modern wallets you use today have a seed phrase, that list of 12 or 24 words. That phrase generates all of your keys automatically, which means you almost never have to handle individual private keys like this anymore. Still, understanding this evolution is key to really getting how Bitcoin works under the hood. So here's the bottom line.
If you ever find yourself handling a raw private key, that format is a critical instruction. A key starting with a 5 tells your wallet to look for one type of address. A key starting with K or L tells it to look for a totally different type. If you mix them up, your wallet will be looking down the wrong street for your house and it won't find anything. So, what started as a simple, kind of goofy paradox about the word compressed actually unwrapped a really clever story about signaling and compatibility deep in Bitcoin's history. It just goes to show you that sometimes the most basic terms can hide the most interesting secrets. And it kind of leaves you wondering, what other simple crypto concepts are we all fundamentally misunderstanding?